In the next few examples, we will be given information about two angles. We're going to call those two different angles S and T. If we're given enough information about those two angles, then we can find function values of their sum or difference. So in the first example, suppose that sine of angle S is 3 divided by 5, and cosine of the other angle T is negative 12 divided by 13. If the angles S and T are in quadrant 2, then we are asked to find the cosine of their sum, so the cosine value of the sum of those angles. Well, notice first that the angles S and T are in quadrant 2. In quadrant 2, what do we know about the sine values and cosine values in quadrant 2? Well, in quadrant 2, sine is positive, so we notice that sine is positive, and cosine is a negative. So we notice that cosine is a negative. So these two angles are in quadrant 2. We are asked to find the cosine value of their sum. So we're going to use the sum identity for cosine. Let's go ahead and write that out. So cosine of the sum of angles S and T would be equal to cosine of angle S times cosine of angle T, and then opposite sign minus sine of angle S times the sine of angle T. So we need to know 4 different pieces of information. 2 of them actually we already know. So we already know sine of angle S. So let's put that in. So we already know that sine of angle S is 3/5. We're going to bring down the minus sign from the formula, from the identity there. We also are given that cosine of t is negative 12 over 13. Let's go ahead and put that in as well. So the other pieces that we don't know would be cosine of angle S and sine of angle t. Now we are given 2 different angles, so we will have to evaluate the cosine value of angle S separately than the sine value of angle t. So let's focus on angle S. We know that the sine value of angle S is 3 divided by 5. What is the definition of sine? Well, we know that's the y value divided by the r value. So we're going to use our Pythagorean theorem. X squared plus y squared is equal to r squared. We don't know what x is, so we will need to solve for x. So y is 3, so 3 squared is equal to r squared, which is 5. So we're going to solve for x here, so we need to subtract 9 from both sides. So we have x squared is equal to 16, and of course we're going to take the square root of both sides to get x by itself. Now when we take the square root of both sides, we always do plus or minus. We want to know which one is it. Is it plus or minus? Keep in mind that angle S is in quadrant 2, and if angle S is in quadrant 2, x is negative and y is positive. Remember that r is always positive regardless of the quadrant. So we're going to choose the negative x value, negative 4. So the goal was to find out what is cosine of angle S. Well, that would be x divided by r. The x value we said would be negative 4, and the r value would be 5. So we can actually come over here and fill out that information. Cosine of angle S is negative 4/5. The last piece of information we need to know is the sine value of angle t. We're going to go through the same process, but this time focusing on angle t. Cosine of angle t is negative 12 over 13. Cosine is x over r. Now where does that negative go? Does it go with the x value or with the r value? Remember we said that r is always positive. Once again, we're going to use our Pythagorean theorem to solve. So the x value would be negative 12. We're going to square that, plus y squared, and then we know that r is 13. So negative 12 squared would be 144, plus y squared. 13 squared would be 169. We're going to solve for y, so we'll subtract 144 from both sides. get that y squared is equal to 25, and we're going to take the square root of both sides. So we have y is equal to plus or minus 5. So if we're working in quadrant 2, since both angles are in quadrant 2, y is positive, so we will take the positive value for y. So what we were looking for is to know what is the sine value of angle t, and that would be the y value divided by the r value for that angle t, which is 30. So we're going to come over here in our formula and put in 5 over 13. So now we know all 4 pieces of the identity. So let's multiply. Remember, according to order of operations, we have to multiply the fractions together before we can do any subtraction. So we're going to multiply across. Negative 4 times negative 12 would be positive 48. 5 times 13, 65. Minus, we're going to multiply across here, so I get 15. 5 times 13, 65. I recommend that you do not reduce so that the denominators will stay the same when we do the subtraction. 48 minus 15, since we have the same denominator, we can keep the same denominator, subtract the numerators across. So cosine of the sum of those two different angles is positive 33 over 65. Alright, in this example we are given that the sine of angle S is positive 2/3 and sine of angle T is negative 1/3. If we know that S is in quadrant 2 and this time angle T is in quadrant 4, we are asked to find the cosine of the difference of those two angles. So since we're asked to find the cosine of the difference of these two angles, we will use the difference identity for cosine. So that would be cosine of S times cosine of T, and then opposite sign, so that would be plus sine of angle S times sine of angle T. So there are 2 pieces of information that we are already given. We know the sine of angle S. We're going to bring down the sine that's part of the identity, and the sine of angle S is 2/3. We do not know cosine values this time, but we do know sine of angle T is negative 1/3. So we know 2 pieces of information, but we need to figure out the other 2. So we need to know what is the cosine of angle S and what is the cosine of angle T. Alright, so the sine of S, we have 2/3, positive 2/3, which makes sense. Sine of that angle S is in quadrant 2, so it makes sense that we have a positive sine value for that quadrant 2 angle S. We know that sine is defined as y over r. So in order to find the cosine value of angle S, we need to know the x value. So we're going to use the Pythagorean identity, our Pythagorean theorem, in order to solve. And we know that y is positive 2, so we'll square that. R is 3, so we have x squared plus y squared, which would be 4, and then 3 squared would be 9. Subtract 4 from both sides. X squared is equal to 5. And take the square root of both sides. Now this time the square root of 5 doesn't simplify. That's okay. We're going to leave it as the square root of 5. So we want to know, is x positive or negative? Well, if we're working in quadrant 2, we know that in quadrant 2 y is positive and x would be negative. So we're going to choose the negative value for x. So cosine of angle S would be the x value, negative square root of 5, divided by the r value, which we said was 3. So now we can come over here to our identity and put in that value, negative square root of 5 divided by 3. The last piece of information that we need to know is about angle t. We need to know the cosine value of angle t. Here we are given the sine value of angle t is negative 1 over 3. So y over r is our definition for sine. R is always positive, so we have that the y value would be -1. So once again, we need to solve for the x value. So y value is -1, so -1 squared equal to r squared, which we said was 3. So we have x squared plus 1 is equal to 9. -1 squared, remember, is +1. And subtract 1 from both sides, we get x squared is equal to 8. Take the square root of both sides. We will need to simplify. We know the square root of 8 would be the square root of 4 times the square root of 2. So that would be 2 square root of 2. Plus or minus, don't want to forget that part. So we get that x is equal to plus or minus 2 square root of 2. So we're going to simplify that radical. Now this time we are told that angle T is in quadrant 4. So let's think about quadrant 4 for a minute. X would be positive, y is negative. So since we're talking about a quadrant 4 angle T, we're going to choose the x value being positive since we're in quadrant 4. So the cosine value of this angle T would be positive square root of 2 over 2 divided by r, which we were told is 3. So let's put that cosine value of angle T in. 2 divided by the square root of 2 all over 3. And now we're going to follow order of operations to simplify this identity. We're going to multiply across. So top times the top, we get negative. We have an outside value of 2, so outside values stay outside. Square root of 5 and square root of 2 multiply together to give square root of 10. 3 times 3 is 9. Plus, so we're going to multiply across. We have a positive times a negative, so we get a -2. 3 times 3 is 9. And we keep the same denominator, but the numerators cannot actually be physically combined because they are not like terms because of the square root of 10. So we can write this as -2 times the square root of 10 minus 2. So we can put them all in one fraction, but we can't actually physically combine those two terms because they are not like terms. So the cosine of the difference of those two angles turns out to be this value here.